All right, in this video, we're going to be working on the circle practice. So to start, number one, what we're trying to do is this woman is running a race. And it says that she is running a 3-lap race with a course radius of r, and we want to know how far she's running. So basically the course is a circle, it tells you, and the distance she is running around is the circumference. So our circumference formula is 2 pi radius, and she is running around this circle 3 times. So I'm going to multiply the circumference by 3 because it's a 3-lap race. So 2 times 3 is 6 pi r. So she is running 6 pi r because she is running around this track 3 times. Number 2, Meg pounded a stake into the ground. She's got this dog, and the leash reaches 9 feet. We want to figure out how much area of the yard does the dog have to run around. Well, area is if you're filling it in, so the area formula is pi r squared. So in this problem, it does tell you to use 3.14 for pi, so I'm going to use 3.14. My radius is 9 squared. So in this problem, all I'm going to do is square 9. So 3.14 times 9 squared is 254.34, which is about option D. So in that problem, we're just trying to figure out how much of the yard the dog has to just run freely, and it has 254 square feet that the dog can run. All right, which of these statements is not true? So looking at this problem, these triangles are identical. We did talk about this formula. And also, we've got some vertical angles, so 50 and 50. The 2 types of triangles that are sitting here, these are isosceles because the segments are the same, and the angles that are opposite of them are also identical. So to find this, I'm going to do 180 minus 50, which is 130. And then divide by 2 to get 65. So each of these angles here are 65 degrees. So now let's kind of go through our answers. Angle TUM is 65, so TUM, that is 65, that is true. TU is parallel to RS. That is also true because we've got our vertical angle, so we know that these are going the same direction because this angle is also 65. So we can figure that out, and that will show you that the lines are parallel. Arc TXU is 50. Well, TXU would depend on what the central angle is because they are the same. So yes, it is in fact 50. RM is congruent to TM. Well, those are both radii of the circle, so that is also true. The one that's not true is K. This segment, RS, is not the same as SM. They are not equal to each other, so this is the false one. Number 4, we're trying to figure out the arc measure of RS. In this problem, you do have to know that these are radii, again, making isosceles triangles. And on isosceles triangles, the base angles are equal, so this angle is also 30. So adding 30 and 30 together, you get 60. 180 minus 60 is 120. This forms a linear pair, which means that this angle is 60. And if we're trying to find the measure of this arc, it is actually equal to the central angle. That's the central angle theorem. So it's also 60. So the correct answer here is option H. It just got kind of cut off a little. So the trick to circles, they're going to use a lot of isosceles triangles because radii of circles are the same, which create isosceles triangles. So you're going to be using them a lot. All right, number 5. Here is a circle equation with the center at 0, 0. It's shifted 3 units to the right. So if I shift to the right, that's a positive 3 direction. And then it shifts down 4, so that's a negative 4 direction. So to put this into the equation of a circle, the center point is 3, negative 4, because this is the x direction and this is the y. But remember, when we're plugging it in, the equation is x minus h squared plus y minus k squared equals r squared. Well, it's already squared the radius, so it's already going to be 37. And then when I plug in this positive, it's going to end up looking negative. And then when I plug in this negative, it's going to change to positive. So I'm looking for a -3 and a +4. Also, just by knowing that 3 corresponds to the x direction, that automatically eliminates A and B because it has the 4 there. So I'm looking for a value where the 3 is negative and the y is +4, and that answer is D. Also, the symbol between will always be positive. So if you see a negative between, that is not right. Number 6, which of the following best describes the plane? We've got a point that's 5 inches from a given point. Basically what that means is you've got all these points around and they are all equal distance. They're all 5. Well, that's created a circle with radius 5. If it was a 3-dimensional plane, it would be a sphere. It's definitely not a rectangle because that's not a thing. It's circles is what it's creating. All right, number 7, what is the equation of this circle? So what I'm going to do here, I have x plus 1, I've got x minus 1. So to find this center, I just count. This is -1 up 2. So -1, 2 represents the center. So my x value is going to look like a positive. So these 2 are gone, leaving me with just A and C. Now to find the radius, I just count. So this distance is 1, 2, 3 units. Remember though, in the formula, it is r squared. So I'm looking for a radius of 9. Well, this 6 is out, and this is the only one that I'm left with. So just remember my formula, or not my formula, I didn't make it up. The formula for circles involves subtraction. If you plug in a negative, it will look positive. And we also always square the radius. Number 8 is a great problem because it involves tangent lines and it also involves equations of circles. So you've got this random circle, okay, and this circle is tangent to the x-axis, which means it's going to just touch the x-axis, and it touches the x-axis at -4, 0. It's also tangent to the y-axis, so it's kind of sitting just on the axes, and it's sitting at 0, 4. We want to know what the equation of the circle is. Well, to find the center, you kind of need to envision these like crosshairs, and they cross here. To get to this point, it's -4 in the x and up 4 in the y. So -4, 4. So looking at your answer choices, the x value, the piece with x, is going to look positive. That cancels those two because they're negative. Next, our radius. Well, to get from here to here, you have to go up 4 units. So the radius is 4, but remember the equation of a circle is r squared. So 4 squared is 16, which is option D. So that problem is tricky. The thing you have to remember is that tangent lines, they don't go into the circle, they just touch the circle. All right, number 9. Same idea, we're writing the equation of a circle. So this is going to be with our x, this is going to be with y. So the 3 value is going to look negative. Crosses these out because those are not negative. Then this is the radius. So we do have to square 15 over 8. And when you square it, it's obviously not going to be 15 over 8. It ends up being 225 over 64, which is option A. Number 10, again, we're extracting the point and the center from a picture. So to get to the center, we go +2 and then down 1, 2, 3. So this center is 2, -3. So remember the middle is always going to be positive, so we can automatically get rid of B and D because the center symbol is negative. So 2, -3, the x value is going to look negative, the y value is going to look positive, so both of those are in. So now our radius measure is 1, 2, 3, 4. Remember, we need r squared, so r squared is going to be 16. 4 squared is 16, so that fits option C. Number 11, given the coordinates of the circle, what is the sum of the x-coordinate of the center, the y-coordinate of the center, and the radius? Well, the x-coordinate is 3 because it's the opposite. The y coordinate is -5 because, again, opposite. And our radius measure is 4 because we have to square root 16. Because remember, the equation of the circle has it already squared. Now we're just adding all those together. So 3 plus 4 is 7, minus 5 is 2. That is just testing to make sure that you know that the center symbol excuse me, is the opposite of what it looks like, and you do have to square root the radius. Number 12, again, we're describing a circle. We have a radius of 8, so r is 8, which means r squared is 64. So again, going through my options, these two are out. Then this one is shifted down 6 units, so that's -6 in the y. It's going to the right 3, so a +3 in the x. So our coordinates for the center are 3, -6, because the x direction has to go first. So in the x coordinate, it's going to look negative. So if I'm going through my options here, the only one I'm left with is B and E, and those actually are the same answers. So you could pick either. That is my fault. I need to change that. But they are the same right now, so B and E would be correct. All right, number 13. Again, we have a radius of 5. So r squared is 25. So going through my options, that cancels these two. Next, we are going up 3. That's positive. And we are going left 5. That's negative. X direction first. So -5, comma 3. So our x value should be with -5. So D is out. The -5, when plugged into the minus, is going to change to positive, leaving us with the correct answer of A. 14, what is the center of the circle? Again, opposite. So the opposite of -8 is +8, and the opposite of +2 is -2. So 8, -2. Option C. Circle has a diameter of 6 inches. What is the area? Well, to do the area, remember the area formula is pi r squared. Well, if the diameter is 6, the radius is 3. The radius is half. So we're going to be doing pi times 3 squared. 3 squared is 9, and the pi goes on the end. Option G. Number 16. This problem is a great problem because it's confusing, but it's so easy. It seems like it's impossible to do. So reading this question, it says that the circumference of the circle is 93 parsecs. This is just a unit of measure. You don't have to worry about that. It wants to know how many parsecs long AB is. So first you have to know how much of the circle that is. Well, there are 360 degrees in a circle, so if I divide it by the 120, I end up with 3, which means this circle is divided into three equal parts. So if I want to find the area of a third of the circumference, of a third of the circle, I would take the overall circumference and divide it by 3, which is 31. So that is the circumference of that piece of the circle. The arc length is 31. Now, it's not answer G. It's not 31 pi because there's no pi in this problem. It's just parsecs. So it's a different unit of measure. So I found the total, divided it, and figured out it was a third of the circle. So I divided the circumference into a third. Number 17. In the figure below, AC is tangent to the circle at C. That means that this is a 90-degree angle. Then it says that you have an angle ABO, which is 120, and we're trying to actually calculate this arc measure. Well, to find this arc measure, we have to go into this triangle, and we have to know the central angle. So in order to help you, I'm going to kind of sketch it out. That is like the worst drawing I've ever done. To find the measure of B, so like this is COB. To find the measure of B, this is a linear pair, so 180 minus 120 is 60. Making the central angle 30. So the arc that it crosses is 30 degrees. So that picture is hard to see because it's very small. And they want you to get lost in your math and pick 60. Because a lot of you will get 60 as an answer, but you'll forget that in order to find this arc length, you need to use the central angle. All right, number 18, the centers of 3 identically sized circles lie on a diameter of the large circle. Each of the 4 circles is tangent to the 2 other. That just lets you know that the circles don't overlap. That's all that's letting you know. It does tell you that the circumference of the center circle is 6 pi. What is the circumference of the larger circle? Well, the circumference formula is pi times diameter, so that lets you know that the diameter is 6. Well, these 3 circles are identical, so that means this diameter is 6 and this diameter is 6. To find the circumference of the large circle, you have to know the diameter of the large circle. Well, it's 6 plus 6 plus 6, which is 18. So the circumference, remember, is pi times diameter for 18 pi. So that problem looks hard, but it's really just the circumference formula, and you're just applying it from small circle to a large circle. Number 19, in a circular pool, it has a 40-foot diameter and a stone walkway that's 3 feet wide. You want to know the area of the walkway. So our end goal here is to find the area of this walkway, which means I need to find the area of the pool, and I need to find the area of the pool plus the walkway, and then I'm going to subtract the area of the pool. I need to remove it. So the diameter of the pool is 40 feet, so the radius is 20. So the first thing we have to do is find the area of the pool. So the area of the pool, and I'm just going to put P for pool, pi r squared. Well, the radius is 20. 20 squared is 400. So the area of the pool is 400 pi. Now you have to find the area of the walkway plus the pool. We want to do both. So this 3 feet, I feel like they purposefully drew it up here to make it look weird, so I'm bringing it down here. The radius, again, is 20, so to find the radius of the pool plus the walkway, 20 plus 3 is 23. So I'm going to do pi times 23 squared. And when I do that, I get an area of 529 pi. Now, in order to find the area of just the walkway, I have to remove the area of the pool. So I have to take my original area of 529 pi and subtract it from just the pool because I want to remove that area. So 529 minus 400 is 129, and the pi just stays because it's a variable. It's just like doing 529x minus 400x. It would be 129x. Pi is a variable just like x. So the area for our walkway is 129 pi. Number 20, the interior angle of a triangle is XYZ. X is 45, Y is 90. What is Z? Well, it is clearly 45. This is a 45, 45, 90 triangle. So you're trying to solve for Z. You can add that up to 180 and subtract, or recognize it's a 45, 45, 90. And last one, number 21, alpha. What is the cosine of alpha? It's 9 over 7. So remember, cosine is A over H. We're looking for the secant. Secant is the opposite of cosine, so that is H over A, which is 7 over 9. Option E.